All right, let's try something a little different today. We're going to take a single product page for a super specialized tool and just pick it apart. We're going to figure out not just what it is, but why it's so incredibly important in our world. And what we're looking at is this, the metallurgical microscope. So, let me start with a question for you. Think about a huge steel beam, right? Or maybe the frame of your car. What do you picture when you think about the inside of it, way down at a microscopic level? Is it just a solid gray block? Or is there something else going on in there, a whole hidden world?
Well, the tool that lets us answer that question, that's what we're diving into. It's called a metallurgical microscope, and it's basically the key to seeing the secrets locked inside all kinds of solid materials.
So what is it exactly? At its heart, it's an instrument for looking at the microstructure of metals. And that word, microstructure, that's the whole game. We're not just making the surface bigger, we're literally looking at the building blocks of the material itself.
Think of it like this. It's the key that unlocks a reality our eyes just can't see. It lets scientists and engineers see these incredibly intricate patterns that decide everything about a metal, how strong it is, how flexible, and whether it's going to break. It makes the invisible visible.
So that kind of begs the next question, right? If we're peering into this invisible world, what are we actually looking for? What are the secrets that this microstructure is holding?
Turns out it's not just random sightseeing. They are on the hunt for very specific clues, tiny little features that have a massive, massive impact on how the material behaves in the real world.
And this hidden world, it really breaks down into a few key things. First up, you've got the grain structure. Just imagine these super tightly packed microscopic crystals that basically form the metal skeleton. Then you have what are called inclusions, which are just tiny impurities or little foreign particles that got trapped inside. And believe it or not, the size, the shape, the way all these tiny features are arranged, that's everything. That's what determines if a piece of steel can hold up a skyscraper or if it's going to crack under pressure.
And this brings us to the who and the why. So, who is actually using these things day in and day out? This is where this tool stops being just a cool science gadget and becomes an absolutely vital piece of industry.
You know, the product page puts it perfectly. These are essential tools for high performance and reliability. And that's the real story. This isn't just about academic curiosity. It's about making sure that the materials we use to build our world are safe, strong, and not going to fail us.
You'll find them in a few key places. In materials science, researchers are using them to design brand new, stronger, lighter alloys. In quality control, you've got a technician on a factory floor checking a sample to make sure a whole batch of steel is good to go. And it's the main tool in metallography, which is literally the science of studying a metal's internal structure.
Okay, and this is where a little bit of detective work gets really interesting. Just by looking at the other products sold on the same page, we can actually piece together the entire story of how a metal sample gets analyzed from start to finish.
See, here's the thing that's really important to get. You can't just grab a random piece of metal and stick it under the lens. The microscope is actually the final step in a really careful process. It's just one piece of a much bigger puzzle.
And just from the clues on the website, we can map out that whole workflow. It's a pretty clear three-step process. First, you prepare the sample so you can even see it properly. Second, you test its physical limits to see what it can handle. And only then, third, do you analyze its internal structure to understand why.
So step 1, prepare. This means using specialized machines to cut a sample, stick it in some resin, and then polish it until it's a perfect mirror. You have to. You're not going to see the internal structure if the surface has any flaws at all.
Step 2 is test. This is where you use things like hardness testers to find the material's breaking points. How much force can it take? How much can it bend before it snaps? This gives you the performance numbers that the microscope is going to help explain. And finally, we get to step 3, analyze. This is where our metallurgical microscope comes into play. Once the sample is perfectly prepared and you know its physical properties, the scientist can now look inside to see the why. Why is it so strong? Or why did it break right at that specific point? The answer every time is in the microstructure. Okay, so that's the tool and that's the process. But let's just zoom all the way out. Why does any of this actually matter to you and me? I mean, how does the grain structure of some tiny piece of metal affect our daily lives?
Well, here's the bottom line. The safety of the bridges you drive across, the planes you fly in, the buildings you work in, it all depends on this. It's all guaranteed by experts using these exact tools, making sure that the invisible world of microstructures is perfectly engineered to keep our very visible world standing strong.
So the next time you're on a massive steel bridge, just remember what's really holding you up. It's not just a big piece of metal. It's an invisible world of perfectly aligned structures, all checked and verified, all to make sure you get safely to the other side.